Here I am going to explain you about a transfer admittance of a given network. So let us consider a given network. This is of a two-port network with the port 1 as input port. The voltage is V1, current is I1. Port 2 is output port, the voltage is V2 and the current is I2. So to find out the transfer admittance or impedance values, first of all we have to transform this network. So here means we have to convert the time domain to a frequency domain. IFT becomes I of s, VFT becomes V of s, and the resistors values become simply resistor values only. And here if there is any inductor value, this value become S into L. So here we don't have any inductors values. And here when you compare, when you are going to transform this capacitance value, this is simply converted to like 1 by S into C. So this value is nothing but here. So this will become 1 by S into C value is 2 by 3. This will become 3 by 2S. Similarly, 2 farads, it is going to transform like 1 by S into 2, nothing but 1 by 2S. So now this is a transformer network. So this is a transformer network. From this transformer network, here we are going to find out the driving point impedance value. We know the driving point impedance is nothing but Z11 of S, which is equal to V1 of S by I1 of S. So here I am finding out the driving point impedance. So when you are going to find out the driving point impedance at the port 1, okay, so here these two are in parallel. So these two impedances are in parallel, like 3 by 2, which is in parallel with the 3 by 2s value. Again this combination is in series with the 1 ohm resistor, so this will be the 1 ohm resistor. Again this 1 ohm is in series with the 1 by 2s value. Again this 1 by 2s value is in parallel with the 1 by 6 value. So this is 1 by 2s which is in parallel with the 1 by 6 value. So here we are going to find out the parallel combination of those two impedances, like R1 which is parallel in R2. This is nothing but R1 into R2 by R1 plus R2. So this value, so I am writing here, so 1 by 2s which is in parallel with the 1 by 6 value, this will become R1 into R2 by R1 plus R2. Upon simplifying this, we are getting this value as 1 by 2 into S plus 3. Similarly, so here we have one more parallel combination value which is 3 by 2 which is in parallel with the 3 by 2s value. So this is a one more combination 3 by 2 which is in parallel with the 3 by 2s value. So this is like R1 R2. So the parallel combination is R1 into R2 by R1 plus R2. Upon simplifying this, we are getting a value of 3 by 2 of S plus 1. Okay, so here I am writing these values. So this value is nothing but 3 by 2 into S plus 1. 2 of S plus 1 are 3 by 2S plus 2, which is in series with a 1 ohm. Again this value is 1 by 2 of S plus 3 value. So upon simplifying this, we are taking the LCM. So before taking the LCM, here I am expanding this value. So which is 3 by 2s plus 2 plus 1 of. So here it is 1 plus 1 by 2s plus 6 value. So here taking the LCM, this will become 1 into 2s plus this value is 2 into 6 is, sorry, 2 into 3 is 6 plus 1 by 2s plus 6. So here I am taking the entire LCM. So this is the value. So upon simplifying this, we are getting a value of 4s square plus 24s plus 32 by 2 into s plus 3 into 2 into s plus 1. Here in the numerator, I am taking the 4 as common. So I am getting here s square plus 6s plus 8. The denominator we have 2 into 2 is nothing but 4, which is s plus 3 into s plus 1. Upon cancel outing these 4 in the numerator and denominator, here we are getting a driving point impedance which is equal to s square plus 6s plus 8 by s plus 1 into s plus 3. But here we have to find out the transfer admittance. So this transfer admittance is which is equal to I2 by V1 of S. Find out that I2 of S. So here I am rewriting this equation. Z11 of S is nothing but V1 of S by I1 of S, which is equal to I1 of S is nothing but V1 of S by Z11 of S. So here I have to find out the I2 of S. Here we have the V1 of S in the driving point impedance value. To find out that I2 of S, here I am applying a current division rule. So that current division rule, which is nothing but the current in that particular branch, which is equal to the total current and into the opposite branch resistance by total branch resistance. So this total branch resistance is nothing but opposite branch resistance with that current branch resistor. So here, so in this network, this is the second branch current I2, which is equal to the total current is here so this I2 is in this direction, I1 is coming in the opposite way, so the total current is nothing but minus I1 again into the opposite branch resistor. So opposite branch resistor is this 1 by S2 value, and which is in parallel with the 1 by 6 value. So this is the, therefore here the I2 is equal to that minus of I1, and opposite branch resistor is 1 by 2s, and here it is 1 by 6 plus 1 by 2s. So this I2 is nothing but the total branch current is I1, which is coming in negative direction, so minus I1 into, so in this one this is the current branch and this is the opposite branch, and this is the opposite branch resistance by this is the entire branch resistance, that is I2 is equal to that minus of I1 into 1 by 2s by total branch is 1 by 6 plus 1 by 2s. Just substitute this value here. So therefore I2 of s is equal to minus of I1 of s into, substitute this value here, this is minus. So upon substituting that values here, minus I1 of s into 1 by 2s by, so upon taking the LCM value here, this is 6 plus 2s by 2s into 6, 2s will get cancelled here, so we are getting a numerator as 6 by 2 of s plus 3. So here 6, 2 1s are 2 3s are. So here we are getting I2 of s is equal to minus of I1 of s into 3 by s plus 3. So here from this one we are writing, here we want to find out the I2 of s by V1 of s. So here already we have the I1 of s as V1 of s by Z11 of s, simply substituting that value here. So therefore I1 of s is nothing but V1 of s by Z11 of s, which into 3 by s plus 3, and I2 by V1 is nothing but that minus of 3 into, substitute this Z11 of s is nothing but s square plus 6s plus 8 by s plus 1 into s plus 3. Here s plus 3 will get cancelled. So here we are getting the final transfer admittance value is I2 of s by V1 of s, which is equal to Y21 of s, which is equal to minus 3 into s plus 1 by s square plus 6s plus 8. Thank you.